Hello, and welcome to IGI's webcast, Why Iterate? Understanding the Essentials of Iterative Development. In today's webinar, Kurt Bittner of Ivor Jacobs International will share with attendees the essentials of the iterative approach. I have a few general housekeeping notes to mention before we begin. All attendees will be on mute for the duration of this webcast. However, if you have a question during the presentation, please type your question into the Submit Question function, and we will attempt to answer all questions at the end of the event. As I mentioned, our presenter today is Kurt Bittner, CTO of the Americas for Ivor Jacobson. Kurt Bittner has worked in the software industry for more than 25 years in a variety of roles. He was a key contributor to the early development of the Rational Unified Process, as well as more recently IBM's JAZ project. His experience includes significant work in banking and finance, relational database system design and architecting, and consulting and mentoring a wide variety of clients on software development, improvement strategies, and approaches. He is the co-author of Use Case Modeling, Managing Iterative Software Development Projects, and Software Economics. IJI is a global services company helping software organizations transform and improve the way in which they develop software solutions, as well as guide them in meeting the expectations of their business. The ultimate goal for every development organization is to produce good software quickly and at low cost. At IJI, our focus and expertise is to resolve issues in the areas of bridging the gap between business and IT, defining requirements and ensuring that solutions meet the needs of the business, meeting project deadlines, and getting teams to work effectively. The company was founded in 2004 by Ivor Jacobson because he realized the need for organizations to work in a smarter way. Transformation is not done by process and tools, it is done by people equipped with experience and smart solutions. I'll now pass the presentation over to Kurt, who will begin.
Okay, thank you, Leanne.
Just take a... And you should now have control, Kurt.
Actually, I think what you did was to transfer to my screen instead of the web. So, why don't you advance the slides and so take control back if you can.
Okay.
Or that work?
Okay.
Try that.
Okay, there we go. You are ready? You have this.
Okay, great. Thank you, Lynn. And
sorry about that.
Sorry for the logistical challenges. It's 5 o'clock in the morning where I live, so I'm still waking up. Thank you all for attending today. What I hope we'll do today is to give you a sense of what iterative development is about and talk a little bit about how iterative development not only can improve results but also give you better control over the projects. So first of all, I think we've all experienced challenges in developing software. Some of the challenges are related to process types of problems, but most of them, as Leanne indicated in her introductory comments, are related to just getting people to work together more effectively. So oftentimes this is because there's ineffective communication between the business, between people on the project team, because it's difficult to get to the heart of the matter quickly. It's difficult to deal with change on the project. There's change in the business requirements, there's change in technologies, there's change in people. And so a lot of these things have driven over the past 20 or so years the development of various kinds of iterative approaches. And so we'll talk in a few slides about what we mean by iteration. But all of these iterative techniques are designed to get people to work together more effectively, to get the people on the project team to work more effectively with the business, and to basically do that in the context of real work and not just passing documents around. So if you apply these techniques successfully, then the results are better. So in the most simple way possible, simple way to express that as possible, you see results more quickly, you get the feedback more quickly, you're able to take action on the feedback more quickly, and that in simple terms leads to better results. So I'm going to move on to the next slide, please. So one of the things I like to keep in mind is that in the traditional project approach, basically the approach is to plan up front, do all your planning up front, and then you execute against that plan. And so everything that you do to determine whether you're on track or off track is relative to the plan itself. One of the challenges with that is that you don't know if it looks like you're off track, you don't know whether it's because you're really off track or whether because the plan was unrealistic to begin with. So this diagram gives you a sense of what iteration is about in a simple sense. You see there's the overall plan in the darker arrow, and that represents sort of the traditional way of planning. In other words, you form a plan and then you execute against that plan. And hopefully you end up somewhere in the stakeholder satisfaction cloud, if you will. In reality, what happens is that things on the ground change and you need to respond to that. So the more jagged line represents an incremental or iterative approach in which you make some small steps toward the destination you want to go, take a look around, essentially get readings on where you are, adjust your path. And so that dynamic target in there indicates that's where you really needed to end up. So at the beginning, you have only a vague idea of what the business wants and what it actually, you have maybe a specific idea of what it wants, but you don't have a very good idea of what it really needs. And so you need to dynamically steer towards that sort of unknown target that exists perhaps in no one's mind at the beginning of the project. So next slide, please. So we'll come to a definition of iteration, and then I'll come back and explain the diagram, this picture in a couple of slides. But basically, you can think of an iteration. Each iteration is a self-contained little mini project. So let's say that you have a project that you expect to last 9 months. You could divide that up into 9 iterations, each of which you can treat like a little mini project where you do a little bit of planning, you do some requirements, perhaps some analysis, design, write some code, run some tests, and get something running. And it's going to be just a small aspect of that system in the first couple of iterations and then gradually build over time. But each iteration is this little mini project, and the important thing is that it results in something that's executable at the end of the project. You may or may not decide to actually release that to anyone, but the iteration, it's got clear objectives. You have evaluation criteria. In other words, how do you know whether you've met the targets? Well, it's because you've satisfied the tests that you've defined for that particular executable result. Generally, you want to have a dedicated team, so it's very difficult to iterate if you've got people spending only part of their time on the project because things are happening so quickly, and you can't rigidly schedule people's time. So it's very difficult if you have developers spread between multiple projects, or even business analysts and testers spread between multiple projects, because things happen too quickly and they miss out, and it simply delays the iteration. Each iteration has a schedule, so it's got a plan, and it produces some sort of executable result. That objective assessment piece is you objectively assess through testing something, so you run some test cases and you get to this executable. Next slide, please. So the concept here is that these iterations then are sequenced so that they build upon one another, and the executable that's produced is gradually built up over time until by the end of the project you have all of the functionality implemented. So you start off with a small executable version of the system, you add some more capabilities onto that by iteration, and you end up with the final finished product at the end. So the real trick or art to planning these is to pick functionality that's interesting enough and complete enough in the early iterations so that then you can build upon it. So it can't just be random functionality, and so as a result, generally you want to plan your iterations around some executable scenarios, and in the early iterations you would implement the basic functionality of something, and then as you get to later iterations, you're adding on, to use the use case terminology, you're adding on alternate flows and exception behavior and things like that. So at each one of those stages, or after each iteration, you want to show that result to people in the business to get feedback. So there's that notion of customer inspection and acceptance. We're not suggesting that every iteration deploys something into production, but you do want to show it to people and get their feedback. And when we say acceptance, we don't necessarily mean a rigid sign-off, but you get their agreement or concurrence that the result that's been produced meets their expectations and they feel like it's on the right track. So it improves the communication with the business for a couple of reasons. It gets them more involved in the front end of the iteration to understand their needs and figure out what you need to build for them, and then at the back end by showing them a result and getting agreement that you're on the right path. So that by itself has a tremendous benefit in just improving the relationship with the business and improving communication. Next slide, please. So this basic pattern, I've had this icon up on a couple of slides now, and the basic pattern of an iteration is quite simple. It's you start off, you come to an agreement on what you're going to do in the iteration, and generally that's you're going to implement certain scenarios along with certain other related supplementary requirements in that iteration, and you're going to test those things. So that's the agree, that's the planning part of it. Then the execute is you do all the things necessary to understand those scenarios, understand the needs behind them, understand the requirements, build the software, and then the assess part of it is that you test it and make sure that it's meeting expectations, that it's correctly implemented the functionality, that in other words that the project is still on track. So this basic pattern repeats, and every iteration goes through this basic pattern of agree, execute, assess. Next slide, please. So iterations by themselves are interesting and useful. We've also found that it's important to layer some other basically decision points on top of this basic iteration pattern to talk about certain kinds of functionality and certain kinds of issues and risks are resolved by certain points in the project. And so in the unified process lifecycle, there are phases. They're called Inception, Elaboration, Construction, and Transition. And I can't claim that those are the most intuitive names, but they've been around for a while. So we've stuck with those names. But basically, each one of those phases deals with a different set of risks and a different set of issues. And there are decision points or gates after each one of those phases to make sure that you've resolved all of those related issues. So the inception phase is mostly about business, is the project viability and business risks. So in other words, is the project worth doing? Does it have, if you build it, will the business benefits come? And so there's a number of things you do to make sure that that's happened. But basically, you've got a candidate solution or a candidate architecture defined. You've got some notion of what the scope is and some notion of what the business benefit, if you deliver upon that scope, would be. So you're still building software, you're still iterating and doing some testing, but the kinds of things that you're doing are mostly, some people might call them proof of concept kind of prototypes to make sure that, one, the technical solution could actually be built, and two, that if you build it, that the business benefits will start to accrue. In the elaboration phase, you're concerned mostly about technical risks. So you take that notion of, can this thing be technically built, and really proving that out. So now you're getting into all of the important non-functional requirements, scalability requirements, perhaps security, throughput, all of those kinds of issues ought to be resolved early. And so you're doing prototyping and building software that's fleshing that out. So you're also usually building out some of the user visible functionality, because one of the big risks is always the users are unhappy or they lose faith in what you're building. So it's a balance between technical risk and these business risk and keeping the business happy. And that differs a bit from perhaps other iterative methodologies where you're primarily doing your prioritization based on the business importance of something. And what that sometimes leads to is essentially ignoring some of the technical architectural kinds of issues that need to be resolved early. So you can still get surprised by those things later if you don't tackle them early enough. So the construction phase is about making sure that you can build the rest of the functionality out. So if we've got a stable architecture defined at the end of the elaboration phase, then in the construction phase, then we're trying to make sure we can build the rest of it out. And at the end of that phase, we've got a release candidate available. And then in the transition phase, we're actually deploying the overall solution. So each one, having this kind of phase structure layered on top of the basic iteration pattern, gives us an ability to more precisely and more systematically control different kinds of risk. It also gives us a better governance structure for an iterative project, because we now have concrete things that we can evaluate basically related to risk, so that these gates are evaluating whether you've mitigated the kinds of risks that are associated with that particular phase. And you should be able to prove that you've mitigated the risk by showing what tests you've executed to prove that those risks have been mitigated. So especially in large corporate environments, or environments in which there's a great deal of scrutiny over project progress and schedule and funding and all of those sort of things, this kind of phase structure gives us a much better governance model. Next slide, please. So I want to talk a little bit more about what happens in these phases, and so I've come up with a series of simplified diagrams that give you a sense of how the work proceeds. So in the inception phase, once we plan the iteration, then we're taking some time to understand the needs of the business. So oftentimes, the reason why I always think this is important is because business people, or the customer, depending on how you view them, will often ask for things that are never used. They'll ask for things that they don't really need. They don't understand what's technically possible very well. And so if you simply write down, or you simply ask them for what they want and deliver that, oftentimes they will still be unsatisfied, because again, they don't know very well what they really need, and they often ask for the wrong thing. So what we want to do is we want to understand the needs, dive a little bit deeper than just asking them what they want. And then we have to go through and explore possible solutions. And so what this means, there may be a variety of different ways that the problem could be solved. It could be that the best solution might be some combination of changing the way that they work as well as technology. It might be all technology, or there might be different alternate technologies that might all yield the same result or a similar result. And when you identify these different possible solutions, then you have to go through and evaluate them. And so you do a little bit of prototyping, show it to the users or show it to the business stakeholders, get some feedback to say, is this the kind of solution that you think would make the most sense, and solve your problem in the best way. So you go through and evaluate those, and then eventually you might have to cycle through this a number of times, but eventually then you find a solution that meets their needs, achieves all the business objectives, including cost and schedule objectives, and then you've got the business viability of the selected solution confirmed. So next slide, please. So then in the elaboration phase, we're taking that specified solution, that candidate solution, and once we've done some scoping and planning, then we refine that solution specification. So what this means, it's perhaps confusingly worded, but refining the solution specification, we've already, through prototyping and through some of the early visioning work, we've already got some sketches of what the system would look like. Now we need to go a little bit deeper. So here we might flesh out use cases, we might gather more requirements, we might do more screen prototypes, we might do more storyboards, might be as simple as just understanding more of the user stories. So there's a variety of different techniques that might be applied here, but they all are involved in refining that understanding of what it is that we're building. And then we develop the increment, so we basically take that incremental increase in work that we've just scoped out, and we develop that increment, and then we evaluate the results through testing. And this, again, this might cycle through a number of times during the phase, and then finally, by the end of the phase, we've confirmed the technical viability of the solution. In other words, we've resolved all of the architectural and technical risks, and we've got something that essentially that we can now start scaling up the development on. Next slide, please. So in the construction phase, the work is basically almost identical, at least in the description of it, that it was in the elaboration phase. We're refining the solution further. We're adding more user stories. We're adding more flows to the use cases. We're adding some more requirements, building out some different scenarios. We develop those things, and then we evaluate the results. The main difference here is that we're now doing that on top of a stable architecture, and we're now, you can think of it as what the elaboration phase does is build out kind of a skeleton of the system, and in the construction phase we're now putting muscle and lots of other connective tissue on that skeleton. So also in the construction phase, oftentimes you're scaling up the size of the team, you're potentially using outsourcing or offshoring or some sort of alternate sourcing model, and you can do that because the architecture is stabilized and you've got components identified, and it's easy to farm those out to different teams and have the result be integrated back into an executable whole. So by the end of the construction phase, then we've got a release that's ready to be deployed out into the production environment. So next slide, please. So then in the transition phase, we basically put that release into a staging environment. We train users. We evaluate whether it's finally all ready to go, and then finally by the end of the phase, we essentially turn the switch and it's running in production. So next slide. So if we do this correctly, what this risk mitigation and focus on these different kinds of issues by these phases do is that it gives us better progress towards the end result. So if you look at the comparison between the traditional project profile or the waterfall project profile and an iterative project, first thing is that you get real results occurring sooner. On the waterfall project, you actually don't start building anything until relatively late in the development cycle, and then things look like they're going fine until you hit some sort of major integration test effort, and then you usually start finding those architectural issues that you didn't encounter earlier, and now all sorts of revisions and change starts. So on the iterative project, it's not that no change happens, it's that we're doing it in more controlled and measured steps, and we're reducing risk earlier, and that's leading to a more predictable profile. So if in a perfect world, the Waterfall project and the Iterative project would finish at the same time, but what happens is that because you find information about the system not really meeting its requirements not until late in the project on the Waterfall project, it ends up delaying the project, and that's why you see a relatively longer time until the thing is actually completed. So it's mostly through risk mitigation, early risk mitigation, that the iterative approach provides a much better, much more controlled way of getting to an end result faster. So next slide, please. So we can look at these profiles. These two lines, the red line and the dashed line, give us kind of the whole picture there. What's happening on the iterative project is that we look at risk early. We see risk rising as we're discovering new issues. So it's rising through the inception phase, but then in the transition, in the elaboration phase, that between that LCO and LCA markers there, you see the risk declining precipitously or very quickly because we're taking an active role in reducing the technical risk on the project. And then as we get into the construction phase, that curve flattens out and we have a much more predictable approach. So it's primarily that elaboration phase work that's driving out risk in a very intentional way. Similarly, the dashed line showing the project progress, and here we mean progress as measured by executed and tested scenarios, that line is increasing. So we're only dealing with a few number of scenarios in the elaboration phase, but they're the most architecturally significant, and therefore they help us drive out the risk much faster. But because we're reducing risk quicker, it delivers business value in a much more predictable way. We don't get that integration test, things blow up and now we've got to scramble around and respond. And it's a much more sort of stable approach to dealing with risk. Now, the interesting thing that oftentimes when I'm consulting with clients, it feels uncomfortable to them because they're dealing with hard problems very early in the project, and it feels uncomfortable, and they know that on a traditional project it feels uncomfortable at the end of the project while you're trying to get everything to fit together, and they start thinking, well, gee, if it's feeling this uncomfortable this early in the project, think of how it's going to be later. And in reality what happens is that difficulty curve follows that red line as well. So you deal with difficult issues up front. You're feeling sort of very uncomfortable at the beginning because there's lots of unknowns and you're grappling with hard problems. But as you get those things worked out and get toward the end of the project, it gets much easier and feels much more comfortable. So it sort of flips around the usual stress levels on the project, puts it up front, but the good thing is that you've got time when those risks and issues are dealt with up front. You've got time to deal with them and get them under control, whereas in a traditional project profile, the risks all happen, you're confronting them at the end, and that's causing a lot of discomfort. So next slide, please. So just a summary of these different approaches. So in a traditional approach, you're measuring progress based on completed activities. So you're looking to see, have the requirements been completed? Has the design been completed? Has the implementation been completed? And those don't really make sense in an iterative project, and also they don't really make sense, I find, in reality. So the problem is, just to pick one of those, is that you don't really know at that requirement sign-off point whether those requirements are complete because what happens is that your users don't really know, they aren't very good at specifying the requirements, and so they often don't know what they want until they see something, and then they start reacting to it and coming up with different ideas. And so we want to get that feedback loop going as quickly as possible. So asking them to sign off on a requirements document isn't very effective because everyone knows that those requirements are going to change, and so the sign-off doesn't really mean anything, and therefore any kind of progress indicator based on that sign-off doesn't really mean anything either. So we want to measure progress based on completed and tested scenarios, because once we've completed and tested it, we know it's done. We know it works. We know it's for the most part not going to change, or it's going to change very little. In a traditional project, it's primarily schedule-driven, whereas on an iterative project, we want to be risk-driven. We want to drive out the technical and business risks early to improve the predictability of delivery. The traditional project also tends to encourage the what we call separation of silos. And what we mean by that is that often in organizations you find that all the business analysts work in one part of the organization and testers work in another part of the organization, developers work in the other. And so the waterfall approach, or the traditional approach, really encourages that separation, and it actually prevents people from working together very effectively. So on an iterative team, we want to bring all those people together, get the interaction going much quicker so that they can be much more effective. So we want to encourage collaboration and break down those barriers. So other things, a few other points, is that the information about where you are on the project in a traditional approach is based on, well, where did you say you were going to be on the schedule and where are you actually? But again, if the completion activities is based around completion of documents, then you really still don't know where you are, because you haven't built anything. You still don't know if anything will actually work. And so we want to get that feedback going as quickly as possible too, and base status and progress measures on the actual executable code and not on production of documents. So next slide, please. So just to wrap up, why iteration is useful is that it allows us to show results faster, even if they're just partial results. And that does a couple of things. It helps us to build support among the user and stakeholder base that we're on the right track. And so it increases their confidence that the team is delivering against what's really needed. So it does that through real executable code, not documents, not sending things around, not having meetings, but actually showing them things that work. So the confidence that they have is much higher. It also increases the confidence of the team itself, because they can actually see real results running as well. So there's fewer unknowns as you get through the course of the project. That leads to improving the probability of success, because by actually reducing those risks early in the project, you remove a lot of the barriers and impediments to success, and that improves the probability of success. So it also, by giving us accurate feedback on progress, it gives us a much better sense of where we really are. So if we know that we have, just for example, 100 scenarios that we need to implement, and we have 67 of those implemented, then without getting into discussion of which one's more complex, we could say that we're 67% done. If we're completed with design, we have a nice design document and nice requirements and everything else, what percent done are we? We really don't know. We can arbitrarily assign numbers to that, but the truth is it may turn out that the design is unworkable, or it may turn out that the requirements are incomplete or perhaps even wrong, and we won't know that until we actually show that to someone. And in my experience of almost 30 years in the industry, I've seen that happen time and time again, where a team will actually deliver something to the customer, and the customer either says, that's not what I wanted, or you find that there's lots of functionality that was implemented that never actually gets used, and something that was almost an afterthought gets used the most. So we want to find those things early, and the iterative approach allows us to do that. The other thing that this does is it provides much better motivation for the team, because you're actually doing something. You can see progress, and it ends up being much more satisfying to work on an iterative project than a traditional project. And it also helps us to be more accurate about planning, because we're planning in smaller increments. It's fairly easy for us to plan what we're going to do over the next month, not so easy to figure out what we need to do 6 months from now on a particular given day. So overall, the iterative approach, I feel like it's it's the only way to develop software, partly because I've been using it really for almost my entire career. It just wasn't called, we didn't use the same terms, but we've been using this kind of, prototyping, early development, risk mitigation kind of approach for an awfully long time. So it's a very proven approach, and increasingly becoming more and more popular in many organizations. So next slide, please. So we've got time for some question and answers, so I'll hand it back to Leanne to take the questions, and I will hopefully be able to shed some light.
Thank you very much, Kurt. Just before I start asking some of the questions, and I do have one that has been put in. So if you do have a question, please submit that in the question function, and we will try and answer them. I did want to mention before we do that, though, we do have the next session in this webcast series is set for February 24th, so you can sign up online. You'll also receive an email tomorrow with a link to sign up if you're interested in signing up for the next webcast called Are You Ready for Iterative Development? And Kurt will go further down to discuss the next stage of planning for iterative development. So Kurt, the question I did receive is, can you let me know which iterative development methodology would be more suitable for different project types?
Right. So I'm very biased in my viewpoints because I like this phased iterative model for a variety of reasons. One is because it helps us deal with risks early. So unlike methodologies like extreme programming or Scrum, which are two very popular methods, and actually I have nothing against either one of them. I think they've got some great techniques. What I like is I like this phased model to be layered on top of those iterative techniques so that you explicitly deal with risks. So you're not just basing the prioritization of stories or scenarios purely on business input, but you're also taking into account the technical risk behind that. So I think that's really important in the work that I do. So you can use a variety of the different techniques that are present in extreme programming and Scrum and layer this phased model or this governance model on top of that, and really not give up anything of those other methodologies, but add some really significant benefits in terms of just the overall controllability of the project by doing that. So I answer the question that way, is that you can use a variety of different iterative techniques, and then on top of that layer the risk-driven iterative phase model and get a lot of benefits. I think that applies to virtually any kind of project. So all projects, regardless how big or small, have risks. Small project, perhaps, you might say a small project has lower risk, but it really depends on what you're doing. So, if you're building, you might have just a very small development team, but building embedded software for a medical device, that could be that could have some substantial risk, some of which might be life-threatening. So, it doesn't really vary on project size. It really varies on the kind of risks that you're going to encounter, and that's what I use to, risk is what I use to drive my selection of what techniques to apply.
Thank you, Kurt. And I have some hands that are raised, but unfortunately I can't unmute everybody. So if you do have a question, I've sent a chat message to those people. So if you do have a question, please send it via the question function, or you can send a chat as well if you have that capability. But there is a question function to send your questions. So I'll just give it a couple of seconds for those people that have hand raised if they're able to submit their questions that way. All right. Okay, so I do have some questions. Great. Thank you. Give me 2 seconds, Kurt. How do you reduce rework in the iterative projects?
So rework, a certain amount of rework is to be expected. It happens on a traditional project in a kind of uncontrolled way, in that you don't really find out what rework you have until relatively late in the project. So the two ways, or a couple of ways to reduce rework. One, the biggest way is to stabilize that architecture at the end of the elaboration phase. And by doing that, you reduce the amount of churn. In other words, it's similar to building a house on top of a stable foundation. So, things that are shared by multiple people, interfaces between common components, ways that things interact, various choices of technology, all of those things get baselined or put under control by the end of the elaboration phase if you're doing doing it well. And that reduces rework quite substantially during the construction phase, where the bulk of the actual development work occurs. So that's the first way. The second way deals with rework in terms of understanding better what the user's needs are. And so early on I mentioned that it's important to understand what the real needs are, as opposed to simply taking at face value what the users ask for. Because those things that the user asks for, often they're not very well thought through and not really related to needs. And so by really probing in and understanding what the real needs and problems are, you can reduce rework and churn later, because you've more precisely targeted what the real needs are, as opposed to implementing just sort of random features. So as an elicitation technique, I like to stay away from asking people what they want, but prefer to talk about what things do you want to achieve, and then we can figure out what different approaches might be able to result in those achievements. So those two major techniques are probably the most significant ways to reduce rework. And then the other benefits are just having the demonstrable software that they can look at, give you feedback on earlier, keeps you from going down the wrong path for too long.
Okay. Thank you. And I do have quite a few questions. We are running past time, but I'll ask, and before I ask this next one, I did have a lot of questions on will this presentation be available. There will be a recording available of this presentation, and you'll receive a link to that tomorrow as well. And I did also have another question, is will we be broadcasting this again? Yes, we are doing another live presentation of this event at 12 noon EST today, or 6 p.m. CET. If you wanted to sign up again. So you do need to go back. If you wanted to sit on this presentation again, you need to go back online and register for the different time. But the next question, Kurt, can this iterative approach be applied to very small projects, i.e. tasks?
I.e., what was the last word?
Tasks.
As a project resulting in something that results in an executable result, yes, this can be applied. This could be applied whether it's a one-person project. I might be misunderstanding the word task, but if it's a task inside a larger project, then I'd say no. That's just an activity or something that somebody needs to do. But the overall project life cycle, in other words, building some piece of software that satisfies some set of stakeholder needs, yes, this could be applied at really any level. Okay. And I think we have time. We'll ask one more, and then unfortunately what we will do, I actually have quite a few questions now, so we will answer each of those questions and get back to you. Does iterative development not impose additional constraints on project management, e.g. resource management and reporting? So I think constraints wouldn't be the word that I would use, but I would use it provides some additional tools to project management to keep the project on track. It does have some implications, as I mentioned, in terms of staffing and resourcing, that you want to have more dedicated, sort of multi-skilled team members overall. you know, it doesn't work as well in a shared resource environment where people are split between many. And I've worked with some organizations where people might be working on 5 or 6 projects, and that kind of model, staffing model, doesn't work very well for an iterative project because it's simply too hard to get any real collaboration going. So you do need to change some of the way that you do project staffing. It also imposes a different set of milestones or a different set of decision points in the project, so that needs to change. And sometimes that's tied into the overall corporate governance model, so that, you know, you need to figure out ways to, or change the governance model and other things to both to take advantage of an iterative approach, and also the iterative approach, as I mentioned, gives you a better way of controlling the projects than the traditional model. But if you don't change those governance models, then you're going to be fighting against that throughout the entire project, and that's a major challenge that I find we work with organizations in trying to overcome that.
Okay, thank you. And maybe we'll try and get one more in, as we do have a lot of questions, but so I'll get one more in, and then we will answer all your questions via email. So budget and resource is an important part of project management, and most of the time you need to forecast for the year. How would the iterative process work in collaboration with this?
Right. This is one of the more interesting and challenging aspects. So the problem is that when you have to budget and forecast for the project, you know almost nothing about what that project really means. You don't know more than usually a sentence or two or a paragraph or so of description about what the goals of the project are, and you're asked to come up with a budget and forecast for that. So a better approach is to understand basically what business value needs to be delivered, and then work backward from that to figure out how much, in a sense, you would be willing to spend to achieve that business value, and that establishes, in a sense, the budget for the project. So that, and then there's usually time to market constraints that also apply. So what you do then is, in the inception phase of the project, your number one goal is to determine whether you could actually deliver those business benefits within the cost and schedule parameters that have been established. And if you can't, then you're better off moving on to a different business opportunity where you can satisfy that. So in other words, you decouple the execution of the project funding from the business benefit funding, and then you use that inception phase to determine whether you could actually deliver in that. So you spend a little bit of money to do and send some investigation around that, and then manage your portfolio of projects that way. So that provides you with a better way of trying to determine the business viability of the project, and leverages the ability to do a deeper dive on the requirements and the needs in order to establish that business viability.
Thank you, Kurt. So we'll wrap it up here, and we will get back to everybody with answers to their questions. And as I mentioned, please feel free to sign up for the next webcast, Are You Ready for Iterative Development? And that's all the time we have for today. Thank you.